We're going to talk about this web-based tool that was created by Howen. I've got Howen with the University of Iowa here, so in case after I get done with this presentation you have questions about this web-based program or tool, he's here to answer that. I'm going to talk a little bit about how we got to this web-based tool and some of the research we've done in Iowa over, well, about the last 10 to 12 years. And it all started with a common problem that we all have, culverts we design culverts for hydraulically handling like the 50-year flood or the 25-year flood. So a lot of times that culvert is wider than the channel, right? And if we have a multi-cell barrel culvert, a lot of times those other outside cells start to silt in. So when we talk about this problem, it's always a hassle to clean these things out, right? Because it's costly. You have to get a bunch of equipment. Your maintenance folks, they tell you after they clean this stuff out, within 2 or 3 years it's silted back in, right? So it's kind of a waste of time. You got 4 different pieces of equipment out here, and they just don't like doing it. Most of the time, too, with a lot of the limitations in maintenance staff or maintenance equipment, a lot of times you have to contract that kind of work out. So how big is the problem? So in our NBIS data, we kind of took a look at all the bridge-sized culverts, anything 20 feet or longer, and looked at them. And based on aerial photography and assessing these sites from your desktop, we found that almost 95% of them are silted in. So a big problem in Iowa. So there's a rundown of kind of the different types of culverts, where they're at, who owns them. But in essence, it's an issue that needs to be addressed. So this is a common thing that you see out there on your rural highways. The stream width here, let's see if I can get the laser, yeah. And what does Mother Nature want to do? It wants to, when you built this culvert, you probably cleaned it out to the right-of-way, to the width, you made the stream wider, but over time, what does Mother Nature do? It wants to recreate its natural channel width and depth, right? So how can we mitigate that? Well, before I get to mitigating it, we did an extensive search of, is there guidelines out there? Is there any national publications that could help us address this issue? And we didn't really find anything. There's really no national method to come out here and utilize. So with the help of the University of Iowa, with their hydraulics lab, we were able to look at some various mitigation alternatives through flume studies, and then down the road here we actually looked at doing some things out in the field. And as part of what when we went out in the field and started looking at these sites, other things came to fruition as far as other mitigation measures. So I'll talk about 3. One is the fillet-based Design A. And if you guys were at the hydraulic conference in 2014 in Iowa City, we had just placed these fillets in a box culvert in Iowa City that was constructed, I think, in December of 2012. So we only had maybe a year and a half of flow going through that location to see if it would work, right? Because when you do things in the flume, you always want to say, okay, that's great, it's in a pristine condition, you're not bringing in debris or other factors that could affect it. So we actually went out and put one out in the ground. Then the other 2 are kind of things that, as the University of Iowa and Howen and others were looking at these sites, this curtain wall method and this downstream weir came up as to possible mitigation measures that could reduce sedimentation in multi-box culverts. So this is a little, just to show you kind of the, let's see if this works. There, see, you can kind of see the flow. And the main thing I want to point out is the recirculation in here and a little bit in here during the low flow. This is where your deposition occurs, okay? And you can see down the middle, it seems to be flowing pretty good, but not as well on the outside barrels. And then in the high flow situation, you get a little better result. Is it going? There it goes. But you still get that same recirculation, okay? And you actually kind of get a recirculation around here too. So what happens over time, you get this deposition, vegetation grows, then you get more deposition, it becomes a vicious cycle, right? So this is when we came up with this fillet or wedges design, where we actually, in the apron, recreate these wedges, and what we're doing there is we're trying to create turbulence so that sediment load will not deposit in those locations but be carried forward through the barrel, okay? And this is what our initial study showed in the flumes. And this is the Iowa City site that you saw in the previous slides, where we have a triple box in here, and this is before they went out and cleaned out the sediment. These are the wedges we put in 2012. And basically they're what we call an articulated mat. It's a mattress fabric that you can pump full of flowable mortar, and it's reinforced both longitudinally and transverse. And these wedges then create a situation where the flow is accelerated through the outer barrels, and we think it will help reduce the sediment process in those outer barrels. So this is in 2012, right after construction. This is an event going through there. You can kind of see the water kind of accelerating through here instead of being recirculated, right? So it's kind of proving out the results of what was in the model. One thing I want to point out, after 4.5 years later, we did get some vegetation growing here, but that was only due to the construction creating a little sag in the wedge here. Actually, what happened is this was not flush, it was concave, and a little bit of sediment sat on there. And in Iowa, if you got just a little bit of dirt, you're going to get vegetation on it. It's going to be weeds probably, but it'll grow. So that we're going to clean up with our next project. The second method that we found that could help mitigate sediment in multi-barrel culverts is what we call this curtain wall or end wall. And this is where we would put a weir upstream of the apron. And then here's an actual site that used this method. And you can kind of see how this has created or mimicked the bank or vegetated upstream and created the natural channel through here. And what that's done over time is basically kind of kept the barrel clean, because that sediment is being deposited in the upstream area, but not through the barrel. In some cases, though, there are situations where on the downstream side, this method does create some deposition, but not so much in the barrel, but just immediately downstream. Again, Mother Nature wants to create its natural channel bed and banks. So there's just another picture of the curtain wall. The third method we've kind of discovered but haven't fully investigated is this downstream weir, okay? And this is where you would create an artificial raised water surface above the culvert bottom, okay? And what this does then, it essentially prevents vegetation growing and sediment depositing in the barrel. So downstream here you can kind of see there's a little weir down here, pointed out. It's just a little rock riffle structure that the farmer built or something to get across. And it's created enough of a water surface up here where sediment hasn't had a chance to deposit and grow vegetation. So we think that this method is another viable alternative to mitigating sediment in multi-barrel culverts. Okay? Here's just some shots of some other weirs that could be constructed downstream. maybe something that you could build that would control the elevation of the water. But we're only talking maybe a depth of maybe 1 to 2 feet in the box, okay? Nothing major, nothing significant. So the weir design is a little bit different than the other two, the fillets and the end walls or upstream weirs, in that this method kind of prevents the sediment, where the other two are trying to push the sediment through, okay? The thing about the downstream weir method is that it is not sensitive to the stream to culvert angle, okay? Sometimes if you have skewed culverts to the channel, it brings in some complexities to the flow and how they get through the barrel. If you have this downstream weir, then that doesn't matter. The downstream weir also seems to be the most cost-effective. The downside is that typically you're going to probably have to build something just a little bit downstream of your right-of-way. So there's going to have to be some negotiating with the downstream landowner to do something like that. And so far, what we've found, it seems to be working at these sites where we've found these weirs located downstream of the multi-barrel culverts, okay? So, in summary, we've fully developed some design guidelines for the fillets. That was the initial mitigation strategy that we came up with, and we do have design guidelines for that. And the other two that we're wanting to try to develop more information and more guidance on is the upstream end walls and the downstream weirs. And I'll talk about a little bit later about a pooled fund study we're wanting to do. Okay? Now the third thing I want to talk about here is the website, the web tool that was developed by the University of Iowa. Basically, the web tool creates an easy, accessible repository for your culvert information. It also is a tool so that you can use it to monitor your sediment in your multi-barrel boxes. And a lot of this can be done on your desktop, looking at images, Google Earth images, or if you've got better aerial photography, you can use those to basically measure with this tool how much sedimentation you have in your multi-barrel culverts over time. And then we provided, through their research, they've looked at different parameters that dictate or can indicate where sediment could occur, right, through various analysis of these parameters. So it's a tool to analyze the potential for sediment, okay? And it can help aid in the design and retrofitting. So what this tool can do, and there's the website, what this tool can do is forecast anywhere in the state of Iowa what the sediment potential is for a multi-barrel culvert. So I can click anywhere on the state of Iowa map where there's a stream, and by giving it some information, it will tell me what the sediment potential is for a site. Okay, so this is some of the, I'll say the graphics that was created by Howen in the website, and it kind of indicates, you know, the top graph, it looks very convoluted, right? You got lines going everywhere. But if you look at the next one down, you got the highly silted culverts, okay? The main thing we want to stress is there's kind of three main drivers that kind of dictate when sedimentation occurs, and I'll talk about that in the slide. But the darker line represents a high sediment. On the left here is your sediment potential, or what is it called? Sediment degree. And based on various factors, a high ag potential, the landscape in Iowa, what the landscape is, and your design discharges, and some other factors, you can say, well, the potential for sediment is very high. Then if you look at specific landforms in Iowa with certain discharges, and the main thing is the ratio of stream width to culvert width. Then that can dictate whether your culvert is maybe going to potentially remain clean or sedimented, if that's a word. It's probably not. So with some measurements, with this tool, you can measure the stream width. Let's say you want to propose a box culvert here. Let's say you got a single span bridge. It's old, it's got high abutments, and you want to put in hydraulically a box, right? Because a buried box is a lot better long term. You don't have maintenance issues with bridge deck overlays or anything down the road. You don't have a guardrail. It's a buried structure. So I want to put in a triple box in here, and that's what hydraulically it tells me I need. So with this tool, I can measure the stream width. I can enter in hydraulically what's required for the box width. And with that, I can determine then whether this box is going to have a high or low potential based on that site for sedimentation. Now, of course, if it has a high potential, then the next step is, what are we going to do about it? Do we just let maintenance worry about it after we build it? Or can we maybe use one of the 3 mitigation strategies that we've looked at Iowa and maybe use it nationwide? Excuse me. So again, this is just a visual representation. There's a lot of information here, but the dots kind of represent locations that have low potential sedimentation, and the darker brown ones have high. So you can see the distribution across the state. You get this graphical representation by the pie chart, and also then the drivers up on top. Let me go back. Okay, I'll go forward. The first thing I just want to point out that I talked about is the stream to culvert ratio. The lower the ratio, or the lower the percentage, let's say the stream is only 20% of the total box width. When you have that situation, no matter what kind of landforms you have, you're going to have a high potential of sedimentation, okay? Now let me go to the next one. So let's say I have a higher, sorry, I can't read the screen and I got to come over here to read stuff. So let's say we have a slightly higher stream to culvert ratio. And as we increase that, you can see that the sediment potential starts to go down, right? Because this is high and then down here is low for sediment potential. And as we increase that, obviously, it gets even better. So there's the 3 different kind of stages, and you can see, wow, when we get even 50% or maybe better, statewide, we can get most of the culverts to stay clean, it seems like. Okay? The other driver that's a big indicator is discharge. Okay? At a low discharge, you don't have a lot of sediment load. So therefore, you do get some locations, obviously, that have a high sediment potential, but for the most part, they're on the lower end. But then when you just increase the flow, not significantly, but just enough, all of a sudden that sediment load comes into play and your sediment potential significantly increases. So discharge is a major factor. The stream to culvert width ratio is a big factor. Okay? But notice when you just get a little bit higher in flow, then it starts to mitigate again, where it's not as much of an indicator for sedimentation of the box culverts. The third one, the main third driver I want to talk about is the landscape. So you look at, we've got different landscapes within Iowa, and no, Iowa's not flat everywhere. We do have some fairly hilly areas, especially in northeast Iowa. So as you can imagine, those landforms, obviously in ag areas, are going to have a lot more sediment runoff potential than what we call our Des Moines lobe, which is where it's really flat, and we don't have as much sediment load. So you can kind of see, I think this is the, I forget the landscape name here. What is it, Owen? The Iowa surface here. You can kind of see a wide variety. You almost have, the pie chart looks pretty equal from clean all the way to heavily sediment. So other factors come into play there where, you know, if you have a lot of forested area, it may show that it's less prone, but if it's high ag, then it bumps up more into the higher sediment load, okay? But then if you take the Iowa surface and you look at a specific discharge, you can say at that discharge, my potential's low. So all these factors are kind of intertwined and interdependent. And Howland, through his genius, has created this to where it can be a tool that can be used, you know, elsewhere across the nation. And again, the same thing, depending on how much flow, it can start to increase the sediment load. So, you know, just to sum up the web tool, I'm just kind of touching the surface of it, but, you know, we can kind of determine based on what the actual culverts have for sediment, what kind of landforms, and some of the factors that went into this program, the distribution of potential for sediment in each one of our landform areas in the state of Iowa. And lastly, I want to just talk about the pooled fund study. I just submitted a request for to do this type of work in a pooled fund study. Go to your research folks or whatever if you are interested in participating. I think this is a good start, and I think down the road this would be a good tool that we could maybe help develop nationwide. Okay? So again, just in summary, the tool we've created is a forecasting tool, so it's a design aid. And we've created some guidance for mitigating sedimentation in culverts, multi-barrel culverts with the wedges. We'd like to get more examples or sites where we can look at both the end wall and the weir, downstream weir, to see how effective they can be more nationwide instead of just 2 or 3 sites in Iowa. And we hope that the pooled fund will create some best practices for preventing sedimentation at culverts in conjunction with our design guidelines for sizing. With that, I'll open it up for questions.
Hi, Dave.
Hi.
It's more of a comment. I'm from Minnesota, and we've used those front-end weirs before for trying to do grade control on culverts. Because we put in a 1-foot weir, and then we could drop the box and lower the slopes and get the outlet velocities reasonable.
Right.
But we found, particularly in fish-sensitive areas, that the fish get trapped behind those little weirs. So you'll see a whole pool of minnows, and then the DNR doesn't like that.
Do you have downstream weirs or an upstream?
Upstream weirs.
And they get trapped?
Trapped behind the weir. They go into that box, and then they just spin their wheels, and it becomes like a little minnow trap. Especially, they don't like it in Topeka Shiner country. So just something to be aware of when you're thinking about putting them in, is you need to look at your fish.
I think we'd like to have you as a partner in the pooled fund.
I think
that's some of the stuff we wanted. That's why we want to do a pooled fund, because that's kind of some of the stuff we need to address and look at. Absolutely.
Yeah, we did a whole study on sedimentation in boxes. So look at St. Anthony Falls Hydraulic Lab. They did it for us.
Okay.
So
they did look at this issue, and did they come up with any mitigation strategies for it, or?
No, it was more of a guidance on dealing with the sediment through the boxes.
Okay.
I had come across some work done in Australia, mill culvert design, minimum energy level. It seems like it's similar to your downstream weir, where you keep water through the structure, and higher flows
It doesn't deposit, it keeps going.
right.
Yeah.
And they have a bunch of tools and whatnot that they've developed. So that's one. Another is their structures are a lot like pressure scour around ridges. And so it's a depression through the culvert that flows at near critical flow at high flows, and then downstream weir to transition the flow back to subcritical.
If you could, I think, Helen, we'd be interested if you can provide that, a link to some of that information, that'd be great.
Yeah, my name is Daniel. You're talking about the high potential segment. My question is that do you consider the Reynolds number for the flooding?
The what number?
Reynolds number.
Oh, I don't think so.
But how do they determine that this is that's flooding minor or big one?
I'm having trouble hearing, but if the Reynolds number, I don't, this is all, what we're comparing are just actual data on the field with all these variables and creating a relationship with them.
Another question is that do you consider the critical depth?
The what?
Critical depth.
Critical depth. I don't think so, Howland. We just ran various flow regimes. We didn't look at critical depth. We don't have a lot of supercritical flow streams in Iowa. We're pretty flat, contrary to what I said about Northeast Iowa. It's still flat in Northeast Iowa compared to Colorado, but
You must be aware of where you end. You just enter the flat, but somehow you can say somehow it's too high or something. The level of elevation is higher than another one. And that's something about that. If you consider that on the flat, it has to be more, more safe about the other conditions.
again, I'm having trouble hearing what you're saying and what the question is, so sorry.
Yeah, I said that maybe we need about the more condition of the surface, not just on the flat.
Right. Well, I think when we did the fillet design, okay, we did look at low flow situations in the flume, and I think based on those low flow conditions with a sediment load in the flume, the fillets were performing accurately or appropriately, and then we put it out in the field, and they still seem to be performing well during low flow and or high flow. So.
Yeah, and then the last one is this one. If we consider the pressure jacket outlet, it's the one that's trying to put outlet and then it's going outside. What is it? The pressure jump.
A hydraulic jump on the outlet? We didn't, supercritical flow was not part of this study. No supercritical flow.
Real quick, Dave, again, good research, and it's neat to follow this over the course of the last couple conferences, and we're getting some good value out of this, I think.
Thanks.
I guess my question to you is this applicable to a single culvert as well?
No, see, the research has just been on triples, right? Because that's easy, because you got kind of the channel down the middle and the two sides, right? We want to go forward with twins, and I don't know if that's really not part of the pooled fund, But down the road, we internally at the DOT, Iowa DOT will probably start looking at twins. But moving forward with this pool fund, we're kind of just sticking with the triples now. So if we can make some progress and looking at other states and what the drivers are for their sediment loads in their triples and come up with some guidance down the road, then, hey, we'll go back and we'll do the twins, and then maybe we'll do another pool fund study for the twins in other states.
Okay, thank you.
Yep.
I don't need a microphone, but are you considering hydraulics too, or are you assuming the tools are negligible for the culvert sizing?
Hydraulics is considered to some degree with regard to the sediment carrying capacity.
So I mean, are you going back and resizing the culvert, assuming, with the 2-foot weir or the?
No, we haven't got to that point. In Iowa, the things we've done is just mitigation strategies. So we have, obviously, the Iowa City site. There's been 2 other designs that have come up that we've put the fillets in. We as a DOT have not done the end weir or the downstream weir method yet. But we want to know more and get beyond Iowa to look at how well this thing performs in other states too.
Thanks, Dave.
All right.